everyone. My name is Fabiana Clement, and I'm co-founder and chief data officer at YData. Just a few words about myself before jumping into the topic that brought us here today. My background is in applied mathematics, and later on, I've specialized myself in data science and machine learning with a master's degree. Numbers have always been my passion, which made data science the perfect fit as a professional career. But as any data scientist, I've also tasted the bittersweetness of AI development. The data is not always available, either because collection was not that great or because privacy constraints just make the access nearly impossible. As many of you know, things just don't get easier when data is finally available. The truth is, more than half of my time was fully devoted to hard and time-consuming data preparation process. It might sound like a cliche, but I have to say, in my experience, 80% of data scientists' time is spent on data preparation. This brings me to the topic that I'll be covering, data preparation under the light of data-centric AI. What is data preparation tuning and how you can, as a data science practitioner, benefit from it? In the last few years, we have all been pumped by the concept of AI and the many advantages it can bring. From automation to business results optimization, the benefits are expected to be huge. All great, right? Sounds amazing, but there's an hidden cost related to AI that many did not predict: the complexity of the development and the technology maturity. Truth to be told, many have been the hurdles, from proper infrastructure to model monitoring. Enterprises that have been investing in adopting a proper AI stack. Nevertheless, and based on the latest reports from O'Reilly, 74% of AI projects never reach production. And what is the main reason, you may ask? Data. More specifically, the lack of its poor quality. The fact is that AI is not yet democratized and easily accessible to everyone or every organization, which brings us to one very important and interesting trend. Gartner expects by 2025, 70% of organizations will be compelled to shift their focus from big to smart data, meaning, in a very simplistic way, improve data quality. And why? Even Google said in a 2020 article, data has proved to have higher stakes in what relates to the performance and robustness of AI models. Bigger data does not mean always better results, but for sure, it means more storage and computational costs. But one question that you might be asking yourselves is, what is smart data exactly? Interesting enough, data quality has many faces or dimensions. It can be described as the data needs to be available, needs to be accurate, require the level of granularity that is right for your use case. Variety and variability are key to ensure generalization and robustness of our insights, and the list goes on. In one paper I've recently read, data quality is even described as having more than 70 dimensions. I know, it's overwhelming, but bear with me. The process of achieving better data quality does not need to be a checkbox, where you need all your boxes ticked. It rather depends on the use case and downstream applications we want to develop. And that's what, in the end, remains to be the most important thing. Data quality is achievable if you are clear on your business objectives for your application. Nevertheless, there are always dimensions that remain key for every single application, such as completeness and consistency, which stands for the accuracy and reliability of the available data for a certain use case. Timeliness, well, is my data relevant time-wise? Is it too outdated? Validity, is my data valid for the use case I'm exploring? So those are definitely key questions. And having in mind this, looks like we are putting more emphasis on the data exploration and processing as well as adding some iteration on the training data set. Should data be the centerpiece of the solution? Well, going from model-centric to data-centric will be key to bring AI initiatives to success. Let me put this into practical terms. An AI system can be oversimplified and described as the combination of data and code. For an AI system to be successful, the right balance between code, or more specifically, a model, and data must be achieved. No one said it better than Andrew Yang, where the model-centric approach is described as the conventional paradigm where data is considered to be a fixed variable in the equation, and code is where iteration happens. Hyperparameter tuning and different models experimentation is what is explored in order to achieve better performance of the ML models. This sounds all perfect and very good when we are working with open data sets from platforms such as Kaggle. Its essence is more or less well behaved, which means that to improve the solutions, of course, the focus has to be on the only element that had more freedom to be tweaked and changed, the code, or let's say the models. But the reality in industry is completely different. And one of the major facts that leads to why data quality is not only hard to measure, but also the tooling available is more limited, is related to the fact that the model-centric approach has heavily impacted the available tooling in the ML space for data scientist teams until now. And don't take me wrong, the model-centric approach had brought us so far with very robust and great models. Nevertheless, for AI to go from the hype to production, a little boost on the data side is needed. And in the end, that boost, it's all about data. Data is the true competitive advantage companies have, and we can see how valuable it can be by looking at the most recent acquisitions from companies like Google or Amazon, the ones that know how to use data properly. And this is why data-centric AI is so important. The reminder of putting more emphasis on the data itself instead of the model. As we like to describe it, the data-centric approach to AI development considered the training data as the centerpiece of the solution, emphasizing it as the iterative part of the equation instead of the model. YData was born out of a personal experience with these problems. And because we know data quality shouldn't be a bottleneck, but rather a stepping stone in AI development, we have created the first data-centric development platform for structured data that help data scientists not only to access the data they need, but also solve the entire use case leveraging state-of-the-art technology. Fabric is our data-centric workbench, and it's split into three major dimensions: data profiling, that allows data teams to quickly assess and understand their data assets; data improvements, where we offer synthetic data as an unfair business advantage to deal with challenges such as privacy, data set imbalancing, or bias and fairness; and last but not the least, data pipelines and model training to scale and ensure a proper data architecture and scalable machine learning flows. By enabling the teams to better understand the existing data, unlocking and enriching it, AI success is at the distance of a few clicks. And where do we stand in the data science lifecycle? The data science lifecycle goes from the problem statement, getting the right data and preparing it, all the way to the model deployment and monitoring. And this is an iterative process. It's not something that we can ship and forget. Not only the models needs attention and the iteration, but the data as well, which is where YData focuses. We are making it much easier to access, clean, and prepare data for data scientists. So instead of spending time on cleaning and preparing it, these teams can not only start delivering, but also improving existing baselines. I know what you are thinking. This seems too good to be true, but how does this work in reality? Well, why don't we find out together? The use case I bring to you today is the development of a credit scoring model, but not any credit scoring development, a data-centric one, while leveraging YData Fabric for the purpose. The data can be easily found at Kaggle under the Give Me Some Credit challenge. While developing this use case, we have kept in mind three main concerns or objectives related to the development of a credit scoring model: bias and fairness of the achieved results, the reliability of the delivered machine learning solution, and last but not the least, results interpretability. Let's take a look at it. So, welcome to YData Fabric. This is our platform or workbench for data science work. And while showcasing you the data-centric approach to solve or develop a credit scoring model, I'll be also giving you a tour throughout our platform and our solution, so you can better prepare your data with YData. We do have at the platform four main components and that we consider to be key for the data scientists to develop any use case. So first and foremost, we have the data sources, which is the module that we use to consume the data that you want to work with. For instance, in considering I'm going to join my project for the credit scoring model, I'm entering the workspace for that project, and I can see that at the level of the data sources, I have already consumed the data that I might need to develop my model. Here at the level of the data sources, I can, besides creating my data source or reading it from storage, I can also get the right profiling and understanding of how that data works. For instance, I can have a very detailed overview on how the variables behave. I can have a very detailed understanding of how the statistics are, what is the data type and variable type of these variables. I can have as well a very thorough understanding of the interactions between each and every variable available at my data set, as well as some associations and how the associations work in between my variables, like how do they correlate in terms of my Pearsons or Spearmans. Well, we can count with a different variety of association metrics to explore, as well as a very detailed and neat visualization on how my missing values are behaving at my data. After all, we want to be sure that whether we are working with missing at random, missing not at random, and what can we do about it when preparing our data. But definitely my favorite section, or the section that I'm usually more concerned about, where I do explore in a bit more depth, is the warnings. So this section is where I can have a good grasp of potential problems or behaviors I should account while preparing my data. So this is where I definitely can explore whether I have high correlations, linearities, imbalanced behavior for some of the variables, whether I have skewness, if my variables are duplicate or my records are duplicate. All of this is quite important because all of this might be problems or challenges that might take a toll in the quality of my data, and for that reason, also in the quality of my credit scoring model, for instance. Now that I was able to really explore and understand my data properly, I can go for the second module, or I can benefit from the second module of YData Fabric, which is the labs. The labs are, in a nutshell, what we consider to be the working space for data science teams. We offer several different IDEs, from Jupyter Labs to VS Code to HTML. And here is where a data scientist can choose between the language and decide in the end whether he wants to use our bundle. We always recommend it if you want to do a more hands-on approach on the data-centric perspective. And finally, you can also select the computation that you want to to have or to offer while developing your models. This is highly useful. And in this use case of the credit scoring, I'm considering the Give Me Some Credit data set. I already have it loaded to the platform. I can have it explored in the labs. For example, it's very easy to go from the data sources to the labs itself just with a code snippet. And here I do have my lab already running where I have explored my credit score. What is important about this use case? I already know that I'm exploring a data set that is highly imbalanced. And that's one of the points that I want to take out of this profiling. So besides being highly imbalanced at the point of my target variable, I know my target variable will be this one. I already know that I have a very low representation of people that won't pay their credit, or I expected to, or in the past have not paid the credit. But they are very not well, so they are not well represented, which means that I have to take this into consideration while exploring my data or while preparing it. Another point that also worries me is the percentage of missing cells. For some of the variables here at the data set, I know that I have high missingness. For instance, the monthly income, which means that I need to take this into consideration while preparing my data set. Let me also explore here. I also have the number of dependents with a considerable amount of missingness, and all of this will impact the development of my model. Through my heat map and dendrogram, I can also understand there is no correlation or real relation between the missingness and the other variables, which means that this missingness is probably might not be at random and might be worthwhile exploring how to impute, for instance. So this is the type of consideration while developing what we call the data-centric preparation of your model data set to build your model. That needs to be important. You really have to explore very well the relations of the variables and understand it well, so you can better decide how you will experiment while preparing your data. And that takes me to the labs and setting a proper data preparation pipeline. Here, while joining at the labs, I can see that I have my data preparation pipeline already ready. And as I told you, I took some steps into consideration. So definitely I want to be able to consume the data that I have already available at the level of the platform. I want to split my data into training and holdout, just because I want to be sure that I'll leave some unseen data to avoid any overfitting. And then I want to be sure that both my holdout and training are still representative, meaning they could be considered taken out from the same population. So I know my results or the measured results do mirror what I want and are applicable and consistent. Afterwards, I do have some data preparation steps that I need to take into consideration while doing and developing my model. So as I mentioned, we do have some interesting cases of missing data. So one of the steps is definitely that we took into consideration is exactly that. So I already know I have at least two variables with missingness that might impact the data set. One of them represents 20% of the data, which is a kind of a high value of missingness. So this means that I might be able, or I might want to explore how first the missingness does relate with the target variable, and that's part of this step, but also how different decisions in terms of imputation impact my end model results and the overall quality of my data. Next, another problem that this data set has also is the presence of duplicates. In this case, we will explore a bit better how much is the representativities of this duplicates in the data set, and whether they might or might not have an impact in terms of the results we will get at the end. And last but not least, and probably one of the major points of this data set, is the fact that it's imbalanced. So as I mentioned before, we do have imbalanced data, and this data in terms of the frauds, or in this case of the customers that are not going to pay the credit, is pretty imbalanced. So it represents less than 1% of the data set. To deal with that, we might decide to downsample or oversample. So downsample the category that is more represented, or upsample the less represented category. For this use case, we have decided to go for the upsampling strategy. And shortly, and with our pipelines, I'll be showing the results of the different experimentations and how they impact the overall quality of my credit scoring model. In this case, and this is so important, is exactly this: the construction of a pipeline that allow us to set up different decisions at the stage of the preparation of your data, and measure the impact of the different decisions at the end of our downstream application. This can be done, of course, for a credit scoring model, but for any machine learning model. And it's core to consider that pipelines are the way for us to make sure we are able to compare the different results. We are sure to keep a track on how each and every model behave, and also make them productizable. That's what the pipelines are here for. That's why they are so important in this perspective of performing a more data-centric preparation. But let's not also forget about how profiling and really understanding the possibilities of preparation is and was for the design of this pipeline, for instance. So with no further ado, and because the pipeline can take a bit to run, I have already made some experimentations that I'll be showing you off at the pipelines module. So going to our pipelines module, this is the module where we build the building blocks of a data preparation process. So each block will be owner of a certain activity and will consist of a flow of data that you are expecting to be done. Pipelines are definitely that element that reproduces this flow as much as you want, with the recurrency that you want to set as well. For the case study that we are presenting in this use case that we are exploring together, I have decided to run my pipeline to improve my credit scoring, or to explore the impact of my data preparation at the level of my credit scoring model. For that, I have here already 3 runs. Each run had a different decision, which I'm going to explore with you. So as you can see, and for a typical credit scoring model, I'm comparing the performance of my model in 4 main metrics: the F1 score, the precision score, the recall, and the ROC-AWOC. One thing I mentioned in the beginning of this use case was the importance of interpretability of credit scoring models. For that reason, have decided to build this use case using a random forest, exactly so we can very easily interpret the end results if we wanted to. So as you can see, for each and every run, I have done a different decision in terms of the data preparation. For instance, in this first run, I have decided to not perform any strategy around augmenting the not represented class of the target variable, meaning I did not augment the cases or perform a synthesization of more records of people that did not pay their credit. I left the data set imbalanced as it was, and I've decided to impute my data set using the median, for example. So this was a test or a validation, how imputing with the median, the missing data, that would impact the performance of my model. I can see here, based on the F1 score and my precision score, that probably this model is not that great. So definitely we have some work and more experimentation to be doing further. I also have decided to do the most simple decision around missingness, as it represents 20% of my data set, which, yeah, might be, it's still a lot. I've decided that instead of imputing the missingness and incurring to the risk of introducing bias to my model, I have decided to simply remove all the missing data and lose some of the information that those records that I'm removing would give to me. At the same time, I also decided not to augment the class that represents the ones that did not pay the credit. That showed me results very close to the ones I achieved by imputing the median. So I can see that there is a slight impact of the imputation of the median, especially at the level of the precision, for example. But that impact is not enough. And here we also still have a model that is not worth to pursue or or to use in a production system. The results are not yet there. So what can be done? What can I explore further? Let me show you one of the runs of this this pipeline, so you can understand better how we can explore, even through the pipelines, the different behaviors and how the data set goes throughout the process and flow of the data preparation. Here, as I mentioned, I have the data set, have my training and my holdout. I want to be sure that my holdout and my training do represent or have the same, or are from the same population. So I ensure the results at my validation are okay. Here I can see that the ratio between the most represented class and then less represented is the same when compared, for example, to my holdout data, which is great. I also can tell by exploring, or for example, having a detailed profiling of my holdout, I can also tell that a lot of the variables do behave the same way on the holdout and training data set, which is reassuring that our holdout was correctly performed and any results obtained on the holdout are valid. Having that, or at the level of the training set, let's say, are still valid. I can also do then a double check and profile better the missingness. We know there is missingness. Does this missingness relate in any way or sort of way with my target variable? Based on this analysis, so analyze my missingness per class of my target, I can easily understand there is no relation. So there is no correlation of the missingness with the target. So the behaviors still remain more or less the same, and that's something we want to be careful and be aware of. Finally, I'm also able to understand how many duplicates do I have. So in this case, 700. It is worth dropping them. Do they introduce too much bias? For this particular case, not that much, but definitely if you have more duplicates, take that into consideration. In this case, we have decided in all the runs I've been showing you not to drop the duplicates, but that's something you should take into consideration, that depending on the size of your data and also the amount of duplicates you might have, it would be interesting for you also to explore the impact of keeping or not keeping those duplicate records. Last but not least, balancing the data or not. So in this use case, I've definitely decided to balance it out, which means that I would augment the less represented class to the extent that the number of records, the more represented class is equal to the number of records of the least represented class. In this step, I also always perform a split. So we have, again, a train validation split. This is always important, even though we are going to compare again our results against the holdout. This allows us to get the most or the least overfitting results possible, and getting or be sure that our results are not being biased or are not optimistic. Being optimistic means that they are too good and they were not representative enough for a production system, right? So that's exactly what all the splits kind of allow us to avoid. In this case, we already can see that there are differences between different models. For example, we have tested from AdaBoost classifiers to decision trees to neural networks. As I mentioned, decision trees are the preferred one, given that our use case does give a lot of importance and emphasis to the interpretability and explainability of the model that we are building. And happily for us, the best or the model that achieved best results at the level of the scores that we want to follow was a random forest. Okay, so for that reason, definitely we are happy to pursue and have good results. So getting back to our different runs and to the results at the level of the holdout, which are in the end the most important ones, we can see definitely that for this run, where we have decided to augment and impute the data set, we have achieved a very good result. So as this is a problem where we want to be sure that we are not giving credit to the wrong customers, or let's say the customers that will more probably not pay, we want to emphasize the importance of metrics like F1 score, and definitely we will give more importance to the precision. And having a look to both of those metrics, we can see a clearly improvement and a big improvement from just augmenting the data set, or in this case, balancing out the least represented and the most represented classes. So here we see almost a kind of a 30% improvement in terms of F1 score, but definitely in terms of precision, we see 8%, which might represent a big advantage for a business. This kind of improvements. In all of this improvement, in all this augment in terms of performance of our model was only achieved with different strategies of processing and preparing the data, being the biggest difference at the level of the augmentation. And as you can see, I was able here to trace back all my experimentations, trace back all my results, and now I'm happy to choose the best decision in terms of the data preparation to solve or to deliver my credit scoring. And this is what it means to do a data-centric perspective or developing a data-centric approach. So my model got better and very good just by tweaking the parameters of my data preparation. I did not hyperparameter tune my model. I can. It is recommended afterwards that we also do that. But definitely we can see here a huge benefit or a huge improvement of just tweaking and getting the data prepared correctly. But one question that might remain for you is how I have augmented my data. So for the process of augmenting or balancing my classes, I've decided to use synthetic data generation, and that was the key core or the key to have variability ensured and generalization ensured at the level of the augmentation. So in this case, we are using YData proprietary synthesizers to do so. As they are data-driven synthesizers, they are able to learn how it looks, the population of the data fed into the synthesizer, and then generate synthetic records or fake records that do match the behavior of the original events or elements. And this allows us to ensure, when compared to options such as Moat or Addison, more variability and generalization of our synthetic data, because definitely that's something we should account for. If we augment the data in an extent that we are just almost copying the already existing events, that means that we are most probably, and similarly to what happens with the duplicates, introducing a lot of bias. And that's exactly what we want to avoid when doing a proper augmentation strategy. By using our synthesizers is exactly that we are ensuring. And just in a simple line of code, you can very easily benefit from learning your real data, how does it behave, and on the other hand, sample synthetic data and have that data augmented to the extent of what you want. Of course, there is a trade-off that should be followed and should be taken in consideration while developing your augmentation process. You have to know, again, very well your data. You have to always explore and profile your data very well so you can have a better understanding on the extent of augmentation that you are able to do. But that's, in a nutshell, whatever you need to do for any single process of machine learning, even as I shown you, just a process of imputation, data imputation. So let me show you very quickly and very briefly how you can, our synthesis process can be very straightforward, or even if you don't want to use code, as we have used here, for example, where we balance the data and we kind of call a synthesizer and we train a synthesizer here, just a line of code. You can also use it through the UI or the experience of our YData Fabric UI. This is recommended for users that want to, for example, generate synthetic data for purposes of privacy, for instance, or are just users that are not so comfortable around code. So as you can see here, I have already a trained synthesizer. It is for a different data set, for a credit fraud data set that you can also very easily find at Kaggle. Here, I train my synthesizer. Depending on the size of your data, it can take a few minutes, a few hours. I can have a very quick grasp on how my data set does behave. I also have access to a very detailed quality report with metrics at the level of fidelity, utility, and privacy. So depending on the use case, you might give more importance to, for example, utility and fidelity, which was the case of the use case that we were exploring here today. But if for privacy purposes, we do recommend for you to take a bit more time and giving more importance to our privacy metrics. After having a trained synthesizer, you can very easily generate a number of different records for your synthetic data generation. It's unlimited. As soon as you have your synthesizer trained, you can do this as many times as you want. And we also offer, just like we offer the profiling at the data sources, we also offer a very easy to compare perspective of your synthetic data and your generated data. So for instance, this is highly useful for you to understand whether your distributions are kept in the synthetic data, for instance. So fidelity is everything that you can have. Besides, it's very positive to be visual, so it's very easy for you to share with anyone within your company and give right away a good grasp on the quality of your synthetic data. So this is in a nutshell YData Fabric. This is in a nutshell the way you can build a data-centric approach, and this is how you can build hands-on, start from today, a more data-centric and focus on the data preparation perspective while developing AI. So just much as models, you can iterate and hyperparameter tune them. Remember that your pipelines and your data preparation flows can also be hyperparameter tuned. And of course, choose always actions for your data preparation based on what you know and what you profiled and explore from your original data. I hope you have enjoyed. It's all from my side for today. And yeah, don't forget that accelerating AI means getting improved data.